Hello, my name is David Lane. Today I'm going to be talking about blockchains. So first a little bit on the history. They were invented by Satoshi Nakamoto in 2008 as a way to secure blockchain transactions. You can think about a blockchain as a decentralized public ledger for anything. It was invented for Bitcoin though. So it was just a way to share and view the information on the transaction history of Bitcoin, as opposed to one centralized institution like a bank controlling it. Now, again, the goal is to bypass financial institutions, and it was invented as a way to solve the double spending problem, which is a problem inherent to digital currencies and transferring money online. Sometimes glitches can occur and you double spend money. Also, digital currencies are very easily reproducible because it's digital information, so it's easy to counterfeit digital currency, unlike physical money. So, blockchaining helps with this. So, what is a block? A block is analogous to a node in a linked list. Except it contains three attributes. It contains its own hash, which is generated when the block is created or anytime it's edited. It contains a hash to the following block, which is, if you want to think about it, an encrypted pointer to another node in this list. And data, which is just defined by whatever kind of blockchain this is. So this is a visual illustration of the structure of a simple blockchain. Block 2's previous hash is block 1's primary hash. Block 3's previous hash is block 2's primary hash, and so on and so forth. And obviously, block 1's previous hash is just zeros or null because it's what we call the genesis block, the first transaction in the history of this blockchain. So now we're going to talk about why we implement blockchains and why they are secure. So they are secure because they use an innovative use of hash functions and hash keys. They have something called proof of work and something called consensus. So the first thing I'm going to talk about is how they use hash keys to secure the blockchain. So let's say in this blockchain I wanted to hack block 2. In doing so, let's say I edit it. Well, now, by the nature of the implementation of nodes, a new hash key will be generated for this hash. That means every node following block 2 is now invalid because block 3's previous hash is not block 2's current hash. So if I wanted to hack this, I would have to go through and change the previous hashes while recalculating new hashes and then changing it to those hashes. So this is already computationally intensive and difficult to implement and hack, but it is possible. So now we're going to talk about proof of work. Proof of work is essentially a problem that's given to nodes or users in the blockchain network that they need to solve in order to add a new node or block to the blockchain. The chain with the longest proof of work is the one that is accepted as the true blockchain. So a blockchain problem must satisfy two properties. The solution to the blockchain problem must be easily verifiable, and finding the solution to the problem must be computational power or must be solved. An example of a problem is something like, given data x, find a number n, such as that the hash of n appended to x results in a number less than y. Simple problem, easily verifiable, just make sure that the value is less than y, and it has to be valid. So these usually require brute force solutions, so you could imagine it would be difficult to hack this for every single node in a blockchain. So this is how I'm going to visualize how we implement proof of work. So taking the previous example, let's assume we have 6 users in the network of this blockchain. And user 1 wants to maliciously edit and manipulate block 2. And while users 2 through 6 are working on adding this new block 6, to the blockchain. Well, in order for user 1 to hack the blockchain, they will need to do the proof of work for block 2 through block 5 and block 6 before users 2 through 6 finish the proof of work for block 6. Now they can all work on block 6 concurrently, and in the Bitcoin blockchain, it takes about 10 minutes to complete the proof of work for a block. So that means user 1 has to finish 50 minutes of work in 10 minutes in order to hack this blockchain. That is feasibly almost impossible, and not a lot of people have successfully done this, if ever. So now we're going to talk about consensus. Consensus is essentially the users in a network working together to verify new nodes. So here we have 3 users. They each have a copy of the blockchain. A new node is created by someone in the network, and each one receives a copy of this new block. They then work to verify, and once it's verified to be a valid block, they add it to their respective blockchains. And they communicate to each other that they have reached consensus. And that is, in essence, how blockchains work in a very high-level, simple manner. So I hope you enjoyed my presentation on blockchains and learned about a new and emerging technology and the way we share and process information. Thank you.